Assalamualaikum and good day everyone. So today we do experiment number 1, which is capacitor. So for the learning outcome, you will be able to determine the time constant of an RC circuit and determine the capacitance of a capacitor using RC circuit. So this is the theory for the total charge, or Q versus T for charging and Q versus T for discharging process. For charging process, the equation is Q is equal to Q naught 1 minus exponent negative T over RC. And then when T equal to RC, we got Q is equal to Q naught 1 minus exponent negative 1. So then use your calculator to find 1 minus exponent negative 1 is 0.63. So this is the graph. Okay, 0.63 from Q naught. Okay, for discharging process, the formula we will use is Q is equal to Q naught exponent negative T over RC. And then when T is equal to RC, we will have Q to Q naught exponent negative 1. So use your calculator, you have 0.37. Okay, for this one, for discharging process. Okay, so this is the formula for charging process and this is formula for discharging process. Okay, let's look at figure or graph I, current versus T for discharging process. For discharging process, the formula will be I is equal to negative I naught exponent negative T over RC. And then when T is equal to RC, we will have I equal to negative I naught exponent negative 1. So I equal to negative I naught 0.37. So that's why we have negative here. Negative just shows that the direction of charging when direction of current when charging is opposite to the direction of current when discharging. Okay, opposite direction to the current flows during the charging process. So here is the apparatus that we will use. We use a power supply, a switch, a direct current microammeter, a stopwatch, a 100 kilo ohm resistor, a few connecting wires, and the capacitor labeled C1 and C2. For this experiment, we use the C1 is 1000 microfarad and C2 also 1000 microfarad. So this is the procedure to do the experiment, but take note, before starting or repeating this experiment, make sure that the capacitor are fully discharged. This can be attained by short circuit the capacitor. So how can we short circuit the capacitor? We can dekatkan kaki anode dengan cathode, so that anode plus cathode, kita dekatkan punya legs, legs of anode and cathode, and then the charge will be fully discharged. Fully discharged until the charge equal to 0. Alright, so this set up the circuit action figure with switch as open, and then record I naught with switch as closed and record I naught. Open switch as and short circuit the capacitor using a connecting wires. You can use connecting wires, or you can do the anode and cathode will be meet together. So then the capacitor will fully discharge. And then close switch as again to charge the capacitor. So when charge the capacitor, the microammeter will be maximum. So the current here will be maximum current. And then simultaneously open switch edge and start the stopwatch to measure the T for discharging process. And then you have to tabulate both I and T. Alright, so this is for experiment number 1. Experiment number 1. experiment number 2, you have to connect capacitor C2. Okay, like this. We have C1 and C2. And then repeat the step to get I and T. And then you have to plot I versus T and also I prime versus T prime using the same axis. And then from the graph, you have to determine the tau, the time constant, and the tau prime of the RC circuit. Okay, and then calculate the capacitance of two circuits using equation C is equal to tau over R. So you have to calculate C1 and also C2. Okay, alright. So we go one by one. Okay, so this is the data tabulation for discharging capacitor for process of C1 and table number 2 for discharging capacitor for C1 and C2. Okay, so we draw the table. Because discharging, so kita punya graph is negative. So we have 10, 20, okay, so T is in second and I is in microampere. Okay, so for table number 1 we plot 66. So the maximum current is 76. Okay, 76 is here. Okay, so we have 66, 16.27. Okay, 16.27 is here. Okay, 66. Okay, lepas tu 56, 37. Oh, very small. So, okay, nanti you kena buat guna apa, graph paper 26. And then I have 46 here. And then I have 36 here. And then I have 26, 36, 91, 26 is here. And then I have 16 is here. Okay, so my graph will be like this. Okay, my graph will be like this. Okay, so this one for table number 1. For table number 2 I have, okay, color lain 66, 30.8, 30.8 is here. Yeah. 56, 71 is here. 46, 118 is here. 36, 182 is here. And then 36, 262 is here. Is here. So the graph will be like this. Okay, so you have to graph. Okay, so for the calculation, okay, calculation for table 1 first. Okay, so kita nak 0.37 from I0. Okay, so tekan capacitor. So 28.1 is around here. So mungkin kat sini dapat dah dalam 110 macam tu. Okay, so we know that. Okay, kat sini tau is equal to RC, so tau 1 R1 C1, so C1 equal to tau 1 over R1. Tau 110, R is 100. Okay, so C1 is 10^-93 farad. Therefore, C1 equal to R1 microfarad. Okay, that is C1. Okay, so for table number 1. For table number 2. Okay, for table number 2. Okay, so kita teruskan. Okay, kita ada dalam 210. Okay, so for table number 2, I letak di sini. Tau equal to R C effective. Okay, C effective. C effective because the capacitor is connected in series in parallel, so C1 plus C2 lah. Okay, C effective equal to C1 plus dengan C2. So C effective equal to tau over R. Tau is 210 second, 100 times 10 power of 3. So C effective equal to 210 bagi 2.1 times 10 power of negative 3 farad, or C effective equal to 2100 microfarad. Okay, so kita nak cari C2. C effective equal to C1 plus C2. So C effective 2100 microfarad. C1 is 1100 plus dengan C2. So we can have C2 2100 minus 0 microfarad. So C2 equal to 1000 microfarad. Okay, contoh. Okay, so kita dapat C1 and C2. Okay, boleh faham Alright, so good luck for your calculation. Okay, so untuk soalan ni kita tak ada straight line graph, kita just ada graph yang macam ni. Okay, make sure you do on your own graph paper. Ni saya just lakarkan saja. Okay, untuk memudahkan you punya pemahaman. Okay, so that's all. Assalamualaikum, bye.